Hi and welcome back. So let's proceed with our project. I think the next step should be, we already kind of know how to record a audio as a wave file, and I think now let's try to apply the Whisper model. First of all, this is still from our Scratch file. I think we should do a bit of a cleanup in the sense that we move this function. Seems to be more of a utility function, so let's move it somewhere else. So let's open the file explorer and maybe in source, kind of in here, audio utils, that's where we put it, and in the Scratch file then it would mean from source.audioutils import record wave. Okay, but we will anyways not need this now. We already have a wave file, which was the voice.wave that we recorded. So kind of how can we apply Whisper? So let's just look at this nice blog post, which I can only recommend from Konstantin Rink. First of all, like here is a nice overview table that shows the different Whisper models, so there are different sizes and also different in whether they are trained on English only or multilingual language. And you see they have different computational requirements. I think for now we'll just take something small because it will speed up the inference. And let's just take this model code here, or this code, and so we import Whisper, and I think we obviously will need to install it. So let's see if I recall correctly. Yeah, Whisper is not a real package, but we need to get it from the GitHub repository. So I can just simply copy paste this, and we should also then where are the requirements? We should immediately add it here, obviously without the pip install. So we have it in the requirements, and then we can also freeze our environment once everything worked as expected. Let's close the file explorer again. Okay, here's the Scratch file. We import Whisper, and then we load a base model. Let's have a look at which size is base. So it's multilingual, and yeah, one of the tinier ones. So I think that's fine for now. Let's make this already a parameter. Model type base, and here model type, and then transcribe. Now we need to give the name of the file name, and what was it called? Voice.wave. Exactly, and then this will be file name. Okay, and then let's see whether it works. Let's make this a separate cell. Okay, installation seems to have finished. The import seems to work, and now we can trigger the model. Problem is, we first need to download the model. So basically, if you install the Whisper package itself, it doesn't necessarily mean that they also download all those models. So it's smart enough that it only downloads the models when they are needed, and then the model will be put into some cache, and cache, whatever it is pronounced, and basically you don't need to re-download it all the time. Okay, and if you recall, what I recorded was when the facts change, I change my mind. What do you do, sir? So it was not perfect, but it's also the small model. But I think, like, from a technical point of view, we already can see that it works. So I think we should put this in a function. Whisper inference, So we need a file name so that we can tell it what should be transcribed. Output text, we put kind of the output result into a text string that we want to return from the function. And what else do we need? Like the model type. I think that's something that you also want to define from outside, but I mean, we could also give it already a default value. Okay, so then let's take that code. Let's move it. So you have the source folder, and in the source folder there should be models. Maybe we could just put it here. So these are all the previously initialized files from the cookie cutter template. Whisper and correct indenting, but obviously import whisper, and then it should work. We have the model type, we transcribe the file, and we return the output. Okay, so in our Scratch file we don't need whisper anymore, but from source models whisper import whisper inference, and then here output text equals whisper inference and model base. Okay, so let's do it this way, and then I think we are already done. So let's just make sure that we restart here so that we can check whether we really get the correct function definition. Okay, all right, so that's good enough. So I think we can also proceed a bit, because it's a bit of a dummy example only. So I think what would be nice is if we can just apply it to some arbitrary audio file. And for that, I think one use case might be, for example, interesting to me at least, to apply it to some podcast. Okay, so now apply model to podcast audio. Okay, so what do we need for that? We first need to find a podcast. So there's this super nice page, listennotes, where it's a huge database of podcasts. There's this podcast show called Freakonomics Radio from also one like Stephen Dubner, and his co-author is, I don't know exactly what his name was, but kind of they also wrote a book, so they're like generally it's a quite interesting and fun podcast. So now we need to find an audio file. So we can see kind of here are the episodes. So this would be the last episode, and so if we look into the RSS feed, and I think you only have access to that if you are logged in on this page here, then you see here this RSS feed, and first you have like more general information, I think, about the show, and then we can see here, okay, now we get to this one particular episode, which is 42 minutes long, and now we need to find the link, and here you see kind of a audio MPEG file is linked, and here is the associated URL, which is very cryptic, but I assume that's just what it is. So audio URL, okay, and then we need to download it. Let's close this for now. So we need to find a way to download this, so we can use the requests package, which I think should be pre-installed already. Okay, and if I recall correctly, it's requests and then I think get. Let's give it a try. And this is some document, and within that document we need to find where the actual content is. And so it's now downloading something, which hopefully works. And doc says okay, content type and content maybe. Let's see what we get. Is it playing now the audio? No, not sure what that was. But I think that should be it if I recall correctly. Okay, let's just give it a try. Okay, so we have kind of content from an mp3 file, and I think we can just write that into a file. And the question is now, okay, got some problems with my laptop, hopefully not noticeable in the video. So kind of we need to write it to a file, and then obviously we need to deal with file paths. I think that actually killed my editor, so let me quickly stop the video. So here we are again. My code editor just crashed. Okay, so we'll need to write that to a file and don't want to really deal with file names. So I think there's this named temp file. Python named temporary file, and we also need to write it to mp3. Let's see. So we definitely, okay, something like that could work. So we need to import temp file. What's going on? Okay, then temp file, and we want to have mp3. And I think there's one tricky option here, which means it will immediately delete the file unless we tell it to not immediately kill it. Okay, and now we have kind of this object, temp file, and from this we can infer the temp file. Okay, there seems to be a problem with the temp file name. Okay. So delete seems to be a problem. Then let's, for now, don't take it. Temp file. Let's see what we. Okay, it's a bit stupid to download all the time the audio again. Still not better. Okay, there seems to be a weird temp file name. Temp file name. Okay, let's give it a try whether it works or not. Okay, so this temp file name. Okay, so that we have the name, and then we actually need to write to it. So there should be a write method, and now maybe this works, but then we would need to reload it. Yeah, but that should work. I'm a bit puzzled about the temp file name. Let me check that briefly. Alright, I think like the first point is that this should be a named temporary file, and then I think we also have the option, delete false. And now hopefully it's better, but it still gives us a rather weird, so that's also not sure whether we need that dot. And temp file, okay, that makes more sense. So if we look now into our file system, so we are in temp, and now hopefully we find this. There we go. That should be it. So I think it worked. So let's put it into a function. So the function should be download mp3, audio URL is the input, and then get the doc so here download, then create temp file, and then write to file, and then if we want to retrieve it, then we also need to know how to find that file again. So then we here get the name of the file. And now kind of a bit of a question, I think, is whether you want to make that file, whether you want to have it inside the function or not, or should you have access to that parameter. I mean, if you have a kind of a bigger project where you need to download a lot of files, and you probably also want to somehow categorize them, store them to retrieve them later again, then I think you would be careful to select paths that make sense to you. So in that case, I think you would hand over a file name yourself. Fname, we could make it probably this way. So if it's none, so if fname, this means the case where we have some fname, else we need to create it. And here in this case, then this temp file name is just fname. So we have a name, but we also then, okay, I need to think about how we then would write it. So this is a to do, and we raise value error function not yet implemented for given fname input. So let's deal with it later to get moving. Then let's put that into the audio utils, I think. This is the function that we had from last time. So what do we need? We need to have the dependencies, import requests, import temp file. I think that should be it. Okay. Then in the Scratch file again, download temp fname, and I need to import it from okay, I think that's good enough for now, and in the next part we will then use that file and probably need to translate it to a WAV file first and then apply our model to it. Alright, thanks.